So now direct and inverse proportion. Okay, so let me just explain. When you talk about direct proportion, kind of like when something is varies directly as something, like for instance now, the higher the temperature, like let me just say for instance now your gas cooker, okay, the more you increase the fire, the more chances for that water to boil. Okay, so you see that the more you increase the temperature of that fire to be more, the more your kettle, the water in the kettle is likely to boil faster. So kind of like the higher the temperature, the higher the boiling. Okay, so that is directly proportional. Both of them will increase. If you increase the temperature, the water too will increase. Okay, that's what is known as direct proportion. So if you want to talk about inverse proportion just means that, like for instance, let me just say you have a cube of ice, like normal ice block now. So let's imagine now that you place it in a temperature where there is heat. So if you put that ice where there is heat, you know it's surely going to melt. Okay, so if you make this statement now that the higher the temperature, the higher the temperature, the lower the freezing temperature of that ice block. I mean that ice block cannot keep won't become freezing again, it won't become ice again to be reducing. So the lower its freezing points, okay, its freezing points. So if you increase the temperature, the ice block will likely to be melting instead of it to normally be freeze as when you are putting it inside the fridge to be more blocked. Okay, so that's like the differentiation between direct and inverse. When we talk about direct, both of them are moving in the same line. When we talk about inverse, one will be increasing while the other will be decreasing, something like that. So looking at this first problem now, direct proportion, the table shown here gives corresponding time and distance for a student walking at a steady speed of 5 kilometers. Okay, as you can see now, the time is increasing and the distance too is increasing, and here the distance is increasing by 5. So for this, while walking in 1 second, person moved 5 kilometers, 2 seconds 10 kilometers, 3 seconds 15. So both of them are both increasing directly. Okay, so this in this phase now, the time and distance are directly proportional. Okay, so you can even show by writing something like this. For example, in 5 hours the student traveled 25 kilometers, and look at this one now, in 2 hours the student traveled 10 kilometers. So you can just, if you divide both of them now, that is this 5 divided by this 5 hours divided by this 2 hours, and this 25 hours this 25 kilometers divided by this 10 kilometers, we're going to have the same answer. That is 5 hours. Remember, this hour is here, that's the unit of time, 1 kilometer is unit of distance, over 2 hours. The hours will cancel themselves to remain 5 over 2. Now let's do for the kilometer. We have 25 kilometer over 10 kilometer. So this kilometer will cancel themselves. So 25 divided by 10 will give us 5 over 2. Can see still give us same thing. All of them, both of them are going at the same pace. Okay, even the question even wrote it, steady speed, so it's going accordingly with the time. So we can likely say that the distance or the time is directly proportional to themselves. This is directly proportional sign, directly proportional. Okay, now for the inverse proportion. For the inverse proportion, the student travels a certain distance, then the greater the speed, the less time it will take. Now you see, one is going up while the other one is going down. That's inverse proportion. So you can see the speed, the more you go faster, let me just say as when you are in a car, the more higher they increase the speed, the more chances you reach your school early. Okay, so just take that illustration like that. So if the student is moving with 10 kilometer speed, the time he will reach will be 10 hours. If the student is moving in 20, it will be 5 hours, 25 4 hours, 50 2 hours. Okay, so this scenario is also known as inverse proportion. Okay, as you can see, the speeds are doubling, kind of. So even this one self is even reducing with a small pace. If you notice, the speed doubled here. That is from 25. If you increase it to 50, it doubled to half of the time, which is 2. Okay, so if we try it now, we say, okay, 50 divided by 25 and 2 divided by 40, that is 50 kilometer per hour divided by 25 kilometer per hour. We're going to arrive at 2 over 1, that is 2. Okay, now let's do it for the same time. Time for the 50 is 2 over 4. This one gives us 2 hours, 4 hours. This one gives us 1 over 2. You can see this is the inverse of this, kind of like the reciprocal. So this is 2 over 1. This one gives us the reverse, which is like the inverse, 1 over 2. Okay, so we can conclude that the time is inversely proportional to the speed. The time is inversely proportional to the speed. Let's represent the speed as v, as velocity. So this is how to write inverse, to be 1 over the stuff. So time is directly proportional to that is inversely proportional to 1 over v. Okay, so it's inversely proportional to the speed. That's it. Or you can say this is the law of the inverse proportion. We're going to apply all this logic in a topic called variation. I think you will do it in SS, variation, and this knowledge of this also applies in physics in drawing your graph. So that's the importance. So let's solve this last question. This last question says that a cyclist traveled 40 kilometers between 2 villages. 40 kilometers between 2 villages. Draw a table showing the speed if the journey takes 1 hour, 2 hours, and 4 hours. Okay, we've drawn the table already now. This is the time. Let's take it as the time. Since everything is hours here, so our unit here will be in hour, and here will be our speed. Kilometer per hour. Okay, so we are given that we have 1 hour, 2 hours, and 4 hours. Okay, and a cyclist travels 40 kilometers between 2 villages. 40. So this place will give us the speed here will be 40. The speed here will be 40. Why would the speed be 40? There's a formula. Let me just show you this formula. Okay, let me just continue the logic first. Since it is traveling at this pace, in 1 hour, the speed of your car will be in 40 kilometers per hour. Okay, if you want to reach the village in 2 hours, that means it will be reduced to 20. If you want to reach the village in 4 hours, that means it will be half again, which is 10. As you can see, this one is times 2, as in they are kind of like squaring themselves. This place now, when we added times 2, as in 2 times 2 here gives this 4. This one now times 2 here. So by this one we are going to be dividing by 2, kind of like half of it. Half of 40 is 20. Half of 20 is 10. Well, let me just show you that logic of getting this time and speed. We know that we are giving 1 hour, 2 hours, and 4 hours, and we are giving a distance 40 kilometers. Distance 40 kilometers. We are giving different hours, 1, 2, and 4. There's a formula for speed. Or let me say velocity or speed. Okay, and it is distance over time. So distance, if it's velocity, to be displacement, so that's saying the same thing over time. So what's the distance? The distance is given as 40. The time is given as 1 for this first one, which is what? 40 kilometer per hour. So that's why there is 40 kilometer per hour. If we do it again for the other one, the speed equal to distance, which is 40, divided by time. The next time they give us is 2 hours. 2 to be what? 20 kilometer per hour. So if we do it for the last one again, speed equal to 40, our distance is 40, divided by our time, 4 hours, is equal to 10 kilometer per hour. Okay, so that's how we can get this table also. Now for the B part, is the speed directly or inversely proportional? As you can see, it's obvious, it's inversely proportional because the time is increasing and the speed is decreasing. So that's a sign of inverse proportional. Okay, so from the table you see that if we double the time, the speed is halved. Like I said this before, so the speed is inversely proportional to time. The speed is inversely proportional to time. So you can write it as a full statement instead of maybe doing this. You can write it that is speed is inversely proportional to time. So lastly, our C part, if the cyclist travels at 18 km per hour, find how long the journey takes. Now given the question says that if the speed here is 18 km per hour, find how long. What is how long? We are talking about the time. We want to find the time, and we already know that our distance is still 40 km between those two villages. So how are we going to get this time? We can make C the subject of the formula from this formula here. Since you know that our speed is distance divided by time. So for us to get this time, we'll make this time subject to the formula, which will then give us time to be equal to distance over speed. Okay, so we have our distance as 40 and we have our speed as 18. So 40 divided by 18 will give us our time finally as 2.22 hours. So that's what it will take 2.22 hours to get there at a speed